In Lesson 10, we are going to be working on adding fractions with sums greater than 2. And remember, sums means that we are adding, or it's an answer to an addition problem. So let's take a look at one of the story problems from the homework and learn through that. Here's the story problem. Angela practiced piano for 2 1/2 hours on Friday, 2 1/3 hours on Saturday, and 3 2/3 hours on Sunday. How much time did Angela practice piano during the weekend? So let's start with our pictures, which includes context, quantities, and then we also want to think about what our whole is and what is the action of our question. So let's start with our context. We have Angela. So I'm going to draw a picture of Angela, and she is practicing the piano. So I'm just going to draw a quick piano. And we know that she is practicing on Friday, Saturday, and Sunday. So from my picture, I can retell my story. Just Angela is practicing the piano on Friday, Saturday, and Sunday. And you want to ask yourself, does this create that picture in my mind of what this story problem is asking me? And the answer is yes. So now I can move on to quantities. I have my quantities here. And that is the Friday hour, so that will be 2 1/2 hours. And I'll just put HRS for hours. Then I have 2 1/3 on Saturday. And then on Sunday, we have 3 2/3 hours. Now we want to ask ourselves what our whole is, and here our whole is going to be 1 hour. Then we want to ask ourselves, what's the action of the question? And it wants to know how much time. Usually when you ask how much time, that's how much time all together. So how much time in all, which usually signifies addition. Now we'll move on to our equation. And we figured out that it's going to be addition. So I am going to have 3 facts in my addition. So I'm going to go ahead and write my equation. So I have 2 1/2 plus 2 1/3 plus 3 2/3. Now, I can't simply add these fractions because they all have different denominators, and I need to have like denominators in order to add. So what I can do is I do have 2 fractions here that do have like denominators, so I can go ahead and add those ones together. So first, when we are adding our fractions, the first thing we want to do is add our whole numbers, and that's the easiest thing to start with. So 2 plus 3 would be 5. And then we will add our fractions, 1/3 plus 2/3, which would equal 5 3/3. And what you'll notice here is I have 3 over 3, or 3 parts in a 3-part whole, which actually makes this equal 1. So I actually have 5 plus 1, which would equal 6. Now I'm going to take this 6 and I need to add it to my 2 1/2 here. So I would have 6 plus 2 1/2. And this is easy. We don't have a fraction here, so I'm just going to add my whole numbers, which is 6 plus 2 is 8. And then I have my 1/2. So our answer in words would be Angela practiced 8 1/2 hours over the weekend. Now, what if you had a fraction that didn't have the same denominator? What do we do? So let's take a look at a problem that would involve that scenario. So let's take a look at the problem 2 1/2 plus 1 3/5, which is problem B on your homework. So first thing that I want to do is I want to add my whole numbers because that just makes it easier. So I have 2 plus 1, which equals 3. And then I have my fractions that I'm going to add in. So we have 3 plus 1/2 plus 3/5. So I took the 1 and the 2 and it made 3, and then I just dropped down my fractions down below. So now I have to ask myself, can I add these fractions? And the answer is no, because I have denominators that are not the same, and I need like denominators in order to add, because all the parts have to be the same size. So for right now, I'm just going to kind of forget about my whole number, and I'll come back to it later. So what can I multiply my fractions by in order to create like fractions? So I'm going to set up my equation, and then we'll take a look. I like to use parentheses just to show what I'm doing with each fraction. Now, I don't want to change the size of the parts that are colored in, but I just want to make those parts into a different size. And the only way that I can keep that the same size is by the rule of multiplying by 1, which keeps the number the same, but changes how many parts we have. So we're going to be multiplying by 1. But we can change or rename that 1 into any fraction that we want. So the conjecture that we came up with was taking the denominator from the opposite fraction and renaming the 1 using that number. So here we would have 5 over 5. And then the opposite fraction for this one would be 2. So we would rename 2 over 2. So now we can create our like denominator fraction. So we have our 3 out here plus our new fraction plus our new equivalent fraction. So our new denominator is 2 times 5, which is 10. And our numerator, 1 times 5, which is 5. Over here we'd have 5 times 2, which is 10. So you'll notice that now we have like units, like denominators. And then out of this one, we have 3 times 2, which is 6 parts. So now I have 3 plus my fractions, and my denominator stays the same because I'm not changing the parts in my whole, but I add the top parts for what I have, and I have 11. Now what you'll notice is my fraction is an improper fraction, meaning there is a whole there. So I can take my 3 and I can split up this 11 tenths into 1 10 over 10, which would be equal to 1. And then I'm left with 1 over 10. So these two right here are equal to that 11 tenths. And then I have 3 plus 1 and my 1/10. So my answer is 4 1/10.